Welcome to a video on fan coil operation. We're doing the logic for this and I have a description of operation that we are working to. So I'll bring across a description of operation first. This is the description of operation, which will be on my other screen, so you'll be seeing me turn into that screen. Using workplace N4, program the following sequence of operation. And we'll go through each one and in the logic as we are doing it. The fan coil unit will operate based on a user adjustable time scheduler, so we need that in there. Internally, initially the fan coil unit will be scheduled to occupied mode Monday to Friday 8 AM until 5 PM. The fan coil unit scheduler will be unoccupied during other times. It will be possible through the building automation system for maintenance personnel to manually control operate as occupied, unoccupied, off and auto. So we've got a few buttons there as well, and we will need the graphic on there. So let's start with the first bit and we'll carry on. So I'll move this back across there. So this is the understanding that you have a Niagara controller. I'm going to use N4.8 for my operating system. That way it can load easy onto, there you go, N4.8. That way it can load easier onto the other modules above this. Where if I did it in N4.13, I wouldn't be able to put it onto a 9 or an 8 or whatever the controller is. So it's always better to write software if you can, I think, in N4.8. So let's get started. So open the station, which is a complete blank station. I just wiped everything out of this station that's on here. And I'm just going to highlight the first bit of the text here on the right hand side. Control key C, and then I'm going to go into my drivers. There's nothing there at all, so I'm going to make a new folder. I'm just going to call it logic for the moment. In fact, I'll move that, so let me just cut that and let me move it into there. Come on, right click, paste, so it's out of the drivers. We've got it in the root there. And then I'm going to make another folder in here called FCU. So it could be for FCU1, FCU2, let's just do FCU1. So that's my start of my folder. I'll put a header up here. So text block, we'll call it header, and we'll put something like FCU control by Paul Maxwell King. We'll put a border around it and we'll give it a yellow background. And we'll just extend that all the way across. And then we could probably put a footer, so let's just duplicate that footer. And then you can put all your details in the bottom of the logic there. I'll just put enter in your tail number and email address or whatever you want. Save that and come back. Now I'm going to put a text block in there and I'm going to do that as a note, and I'm going to paste in the first section that they've asked for. Clipboard is empty, go back onto that side, control key C, control key V. Right, that's going to be a long bloody line, so let's try and simplify it a little bit. So fan coil based on user scheduler. Let me just put that into a text file on this side. In fact, I'll bring that across here. Control key V, user schedule, initially fan coil to 5 PM, that would do. Click that off there, that would do. Turn that to there. Okay, now do a copy. Go save, come back out, and then move that across so we can see it. There's no harm in putting the description of operation into your logic. At least you'll be able to follow it from what they wanted originally. So based on user adjustable scheduler. So let's put a scheduler in here at the moment. So let's go to schedulers. Here we go. And we'll put a Boolean scheduler in there. And we'll call it FCU schedule. And it says from 8 AM until 5 PM. Monday to Friday. So to 5 PM. That's 7:30 to 5. 8 AM to 5. Apply Monday to Friday. And let's go into our properties. And we'll call it enable, disable, or on or off, whatever you want to use. Okay, save. So that's our scheduler done now. Then, so we've done that Monday to Friday. The fan coil unit schedule will be unoccupied during overtime, so that's fine. Okay, so let's do occupied and unoccupied. Seeing what word's being used. Occupied, unoccupied. Okay, save. It would be possible through the building system for the maintenance personnel to manually control operation as occupied, unoccupied, off and auto. So there's going to be an off and auto switch. So let's put them in there. Is there going to be an AND switch? I'll read through a little bit further just to see. Occupied mode, no. Unoccupied mode, don't want that at the moment. Off mode, as an off mode. There doesn't seem to be a hand. Override on, override off, and there's an override mode and an auto mode. Okay, I can't see her. So it's just going to be one switch, which is off and auto. So let's just do a switch. We'll call that mode. And I'll take out in 10 and in 16, and I'll put in a set, and we'll go mode as false as off and auto for on. The fallback will be off. Save that. And then what we'll do is we'll go into our AX slot sheet and we'll click on emergency active, and we'll keep our finger on the shift key, click on auto, right click, config flags, hidden. So they're all now hidden, and the only thing that we can see is the set. So now when we right click that, actions, all we see is the set and not emergency override or anything like that. So that's the first bit. Let's have a look at what he's saying here. So again, let me just run up a text file. Let me paste that into the occupied mode. There, there, and there. Control key C. New text block. Note it will put it to note 1. You see this here, right? See note 1 has just come in there now. That's your note. That's your note 1. I just type note, but it will put it to the next available. Let's just move that across there. So occupied mode. Let's see where we are with it. Let's just put that right across to that side. That right across to that side, so we're not interfering with this, with the logic. Occupied mode. When the fan coil unit is in operation, occupied mode, okay, the supply fan will run continuously. Right, let's put a supply fan. Boolean writable. Supply fan. And it's not asking for this, but let me just take out in 16. I just like it tidy, that's all. And let's do a set to false at the moment, and I presume we will change that facet to enable and disable. Go OK, save, come back out. I'm going to get supply fan on my left hand side here, and then I'm going to go to my kit control, and then I'm going to go to my control palette, extensions, and I'm going to take a discrete totalizer across. We haven't asked for this. So there's my discrete totalizer. I'm now going to right click the supply fan, go to composite, and I'm going to put in, do I need change of state time? Yeah, why not? Change of state count, how many times it's stopped and started, and elapsed active time. And then we better do a reset for them as well, in case we ever need to reset them. Good. Let me just put a single shot in there. So let me go to the timer and a one shot and reset maintenance. Pin slots, take out that, take out, add the fire, take out the out not. I'm going to change that text to resetting and reset maint. And we can take that fire, put it in there, and put it in there just so that we can actually reset everything. Right, in fact I'll take that and put that right up at the top, out of the way, so it doesn't interfere with anything. Occupied mode, when the fan unit is in operation. I'll tell you what we've not added a fire alarm, because we don't want it running when there's a fire going. We don't want to be moving air, so let's just put a fire alarm. We could just call it safety. We'll call it safety. Pin slots. And we'll make it fail safe, so that means it's going to be true is healthy. Let's put in no fire, healthy. We'll record it safety, so we'll put in fault, exclamation mark, instead of no fire, because we just called it safety. We'll put the fallback in as true at the moment. Let's put it healthy as a fallback. So now I'm going to just give myself a AND gate, logic, an AND gate, bring that across there, put the out into there, put the mode into there, and put the healthy into there. So that's my start FCU. I'm going to set that to auto. And our safety, I've got that, have I got that the wrong way around? Truest fault. Yeah, I got that the wrong way around. Fault. No, I haven't. True is going to be, oh yeah, true text, fault. False text, a healthy. Save. So if anyone cuts the wires or anything like that, it will go to false. Let's set that to healthy. So we've got our true signal there, and we're waiting for the schedule. I'm writing this at 6:47 in the morning, so hence that's why the scheduler is not on at the moment. Okay, operation mode fan coil will continuously run. Mode of the supply fan will continuously run. So don't we need a time limit to turn off the fan coil? So when the enable's gone off, wouldn't you want to run on time of say 1 minute, just to take any heat that's in the coils? You haven't asked for that though. The chilled water valve and hot water valve will modulate according to the maintenance of the space temperature set point. So right, we've got another set point there. The chilled water and hot water valve will not open at the same time. Yeah, we can do that on a PI loop. So let's do a set point. New numeric writable. FCU set point. Action set, and let's put that at 20. Oh, we're in Fahrenheit, aren't we, here on this job? Occupied space set point is 72 Fahrenheit. Normally don't work in Fahrenheit, but let's see how we go. So we don't need any of them, and we've got the set point in there. We better change that to Fahrenheit. So we'll go to temperature and Fahrenheit. Okay, and we'll just have one, we won't have any decimal places after it. In fact, what we want to do is, like I said, I don't know Fahrenheit, but I don't think you would go, if 72 is like about 21 degrees C, I don't think you want to be going any more than 80. And minimum, I don't know, I'll put, if that's 72, I'll just put 60. You've got to excuse me, I don't normally work, like I keep saying, in Fahrenheit, but yeah, if it was a centigrade, I would say around about 21 for the space temperature. Don't go ever below 16 degrees centigrade, and you don't want to go above 25 degrees centigrade. But anyway, the chilled water valve and hot water valve will remain open at the same, will not open, yeah, that's okay, to maintain space temperature, so chilled water valve. So let's do a PI loop, proportional integral, and we'll call it valves because we're going to use the same loop for both valves. That way they won't open at the same time. Pin slots, let's do control variable set point loop enable is an important one. We've put our prop on our int in there, and we'll do our minimum and maximum, not that we're going to be changing anything there, but you are going to see that I'm going to change that to -100. I'm going to put a prop in. I normally use 2, I'm going to put something like 6 in there, and I normally use a 1, and I'm going to put something like a 3 in there. Save that. So in order for that to work, we definitely will need a temperature. I'll tell you what, let fan coil set point, let's just check that we hide everything to do with other objects we want. So we've just got the set there, and then let's go to another numeric writable and FCU room temp or return or whatever it's going to be, but that is going to be our control variable for our fan coil unit. And we'll take out in 16, that's going to be Fahrenheit. We don't need our min and our max, so minus inf plus inf. Okay, save. And we'll sit something in there at the moment of, I don't know, 70 degrees, so it's colder than that. Put our set point into there. With our loops true at the moment, but we will move that once our scheduler, in fact, let's put our scheduler on for Sunday. And let's just put it on them times just for now. So we've got a true coming in there. And our control variable is there. And we've gone to straight -100. So that's our cooling. So we want to do cooling. So we're going to take that figure and we are going to put a a minimum block in there. So maths minimum cooling, put that into there, and then put that to 0. So it will register anything from 0 to -100. Then we're going to put an ABS in there, so we've always got the figure as a positive value. Take that, put that into there, so that is our 100%. We can put a percentage on there so it looks nice. So that's our cooling valve. New numeric writable. Cooling valve. Again, we'll put that as a percentage. And I will put a discrete numeric totalizer on that. Not that it's asked for it. Pin slots, take out 16. Composite that. And we'll have total time of total reset. We'll have it all. Let's just take it all. Let's bring our reset for maintenance, and we'll put it into there, and we'll put that one into there, and we'll duplicate that, and we'll change it to heating. Put that down there, bring our resets in there. So that's our cooling coil at the moment into there. Our heating coil, we want a maximum block now. I think you can see where I'm going with this. Maximum block heating. We'll put that into there, and we are going to put a 0 in there. And then we don't need an ABS on this particular one because it's always going to be a positive value. And that's our heating. So let's change our room temperature. In fact, that's set point is 72, room temperature is 70. I want to be doing heating, not cooling. So let's just reverse that. So I'm at 100% heating, which is in there. Now we're going to put our room temperature higher than 72. So let's set that to say 80 degrees. So that's our cooling valve closing. Let's just space it a little bit more, just so it gets it done faster. 85. And that's our cooling valve opening. So that's your 85 above 72. You want cooling. That's our cooling valve opening, heating valve. So you will, the chilled water valve and hot water valve will not open at the same time. Well, it's impossible for them to be open at the same time because of this logic here is stopping that from happening. Let me put my loop into there, so my loop's enabled. Let me just move them down a little bit just so this looks nice, neat and tidy. Right, I'm going to take that and put that to there, and for the moment take that and put that to there. Now they did mention some overrides, didn't they? They got the off and auto, but further down they wanted an over. Well, we'll probably come to that in a bit. So have we done that? When the fan coil unit is in occupied mode, supply fan will run continuously. So we want the supply fan to run. So we can either take it from there or we can take it from there. I'm not bothered which way we do it. I'll take it from there so we can probably see the wire, the link. So we're enabled 100% cooling because we're at 85 and it's 72 set point. So we want to cool down. Safety is healthy. So there's no fire. So that's all good. Mode is auto. Naturally we turned it to off, everything would stop because that's an AND gate. Fan coil goes to off, that would stop, that's an AND gate. And of course with the safety goes to false, that would stop. Let's just mark them up. Views, scheduler, schedule, mode, safety, good. Room temp. Okay, next one. that was B, occupied mode, unoccupied mode. So let's just copy that. Control key C. Take that. Control key V. Be off. Okay, so let's just, we'll put that down. No, control key Z, we'll do that, we'll put it down there. That just makes the spacing the same. Control key C, new, text block, this is going to be 3. When I put a note there, it will change it to 3. Paste that into there, save. That was the first bit. This is the second bit that we've got to work on now. Unoccupied mode. During unoccupied mode, the fan will be off. Okay, yeah, I can go with that. So let's put it to unoccupied mode. Let's just move that down just for the moment. Save. If the space temperature falls below the unoccupied heating set point, we've only got one set point, the fan will turn on and operate in unoccupied mode. If the space temperature falls below the unoccupied heat, oh, we're going to have another unoccupied heating set point. That must be further down. Oh yeah, here we go. Unoccupied heating set point. So let's just add them in. That's on the next one down. So duplicate, unoccupied set point, unoccupied heating set point, and they've set that to unoccupied heating. They want 60 degrees. 60, yeah, 60 degrees. Save, which is actually the lowest on our schedule, so that weren't a bad guess on my part. And we've got an unoccupied cooling set point. Duplicate, unoccupied cooling. You see this later on when I paste the desks across there. Unoccupied cooling set point 85. So that's 85. So I'm going to put 85 as the maximum there. Okay, save. And set that to 85. And then I'm going to set my fan coil set point maximum, because it looks like the range that he wants is between, or she wants is between 60 and 85. So that's my unoccupied cooling set point. Was there anything else? Occupied space temperature set point 72. We've already mentioned that there. The base will automatically subtract 2 degrees Fahrenheit for heating set point and add 2 for cooling set point. Okay. We'll automatically subtract 2 for heating set point, so we need to just do that. So that's our set point there. The problem is we would need to know now whether they were in heating or cooling, because we've done 72. They've used that this is written really for a T-stat and not one of these, not a PI loop, because you wouldn't really need to do the -2. I don't know what to do there. I don't know whether to write it in T-stat or leave it as it is, or use that. And yeah, so we'll just do a bit of calculation here. So if our room temperature is above the fan coil set point, so greater than, we will do it that way. So greater than, and we need a little bit of a leeway as well, so we will use a T-stat in there. So let's go to our T-stat and we'll name it in a bit. Pin slots, diff set point control variable. So that's our set point at all times, and that's going to be our control variable at all times. Let's put a diff there of just 1. That's 0.5 either way. Take that off, save. So we are in cooling mode, which we've got a nice true there. So when we're in cooling mode, we want the set point. Let's do a numeric switch. Numeric switch. Cooling mode. Set point. Rename that. I've just done, yeah, I've done a cooling there. I'll just put cool then for that. You can't have two names the same. I was going to put CLG, but I've already got CLG there. So numeric switch in. Now we need to add 2 degrees. Is it so? What it says here? Subtract 2 to 3 and add 2 for cooling. So let's add 2 degrees. Add. So set point plus 2. Save that. I'm going to do set point plus 2. Okay. And we put that into our true. We take that baby out there. And we put our new 74 in there. And what we'll do is we'll do give it a facet Fahrenheit. So used to working in centigrade, sorry about that. Oh, you're going to put centigrade Fahrenheit. So true is cooling. That's set point. And if it's going to be false, which is going to be the other way round, so let's put this now to actions set to 70 degrees. That's now false, so we're going to do a subtract. Set point -2. We'll take our set point again, put it into there, we'll do our -2. Save into there. And that's 70 degrees Fahrenheit. Save. And we put that into our false. And that's our 70 shown there. So that's not just cool, that is cooling, heating, set point, select. Let's just tidy this up now. Ish. Tidy-ish. So that is our set point +2, which is our cooling, and that is our heating. So cooling and heating. Views, AX slot sheet. True is cooling, and 3 is heating. And then let's change our set point again. Actually, not our set point, our control variable. Set that to 80. And we've now got a 74, which we want to be doing cooling now, which we are. So that's done for that one then, which is a bit further down. I haven't seen that one yet. Let's carry on now with the during unoccupied mode. The fan will be off. Yes. If space temperature falls below the unoccupied heating set point, the fan will operate in unoccupied heating mode until the temperature is 3 degrees above the unoccupied heating set point. Okay. Duplicate. We're going to rename that anyway, but I'll just duplicate it at the moment. The space temperature falls below the unoccupied heating set point. Unoccupied heating set point is 60. Space temperature is that, which is my control variable. So if the space temperature falls below the unoccupied heating set point, the fan will turn on in unoccupied heating mode until the space temperature reaches 3 degrees. Oh, okay, so you just want it right below that. So just it's T-stat then. We don't need a T-stat as such. We could just use a normal below there. T-stat's better though. If the space tab, because you've got that little bit of dead band that you can work with. The fan will turn on and operate in unoccupied heating mode until the space temperature is 3 degrees above. So we're off. So we need to be off as well. So we need an AND gate in there. AND gate. Because we need that into there, which is going to be our control logic. And we need an AND gate. So we need to put a NOT in there. And safety. We've got safety there, and if safety's not on, we definitely don't want that. So what we're going to have to do, we still want to keep our safety in as the last bit, but let's take that out of there and put our in and out there, and then we stick another AND bit up there. Start FCU, and we'll put our, we're going to have a few of them in there now, aren't we? Let's put our safety back in there first, but I would need an OR gate in a minute. Take that out of there, put that in there, because we will need an OR gate for even if it's off. So I've already used start FCU. Let's put an underscore there. Take that in there. So that's our scheduler there. So we can put that into one start. Use AX slot sheet, and we can put that as normal. The other one was so unoccupied heating. Unocc heating is going to be my next one. And we've got an unocc cooling. Pin slots are not cooling. Right. So that is an enable, that's my safety. Views, AX slot sheet. ENB, safety. They didn't ask for safety, like I said, I've added that in. I just think it's, you don't, if there is a fire system, you don't want to be running the fan coils when there is a fire alarm. Right, back to this one now. If the space temperature falls below non-occupied heat pump, the fan will turn on and operate in occupied heating mode until the space temperature is 3 degrees above the heating set point. So it's going to work on, so as you're unoccupied, and it's got to get to 3 degrees above that before it will actually start. So we can turn it on when it's lower than that. So let's just, so we've got it on at the moment, let's just change that. Let's put that to reverse, and let's put that to a really low value like 0.2. And let's put that, we're unoccupied, let's put the temperature down to 71 because we're below set point. Oh no, we want to put it down to 59. So that puts it on. So that is our unoccupied heating. Rename unocc heating. And then we need the NOT gate in there, which we've got there. Let's just move this slightly across so that I can see what's going on there. So that's our, and rename unocc heating. So that's our scheduler off. Whoa, no, if mode is off, yeah, it's still going to be, if mode is off, that's fine. So our scheduler is off. Yeah, because if mode is off, then fine, you don't want that running because there's a fault or whatever, so let's leave it like that. So that is going to be our enable, and that's going to be unocc. So enable, and that's my unocc. And that loop's not going to go there now. That loop is coming from after the safety. That's my loop enable. And we want to put that from the true bit into there. So that's our unocc views AX slot rename unocc. So that's us switching the baby on. I just put that in the wrong one. That's right. I haven't even done it yet. So that's us switching it on our heating, which has switched it on and put that open heating valve. And then they say unit space is 3 degrees above the occupied heating set point. So we can turn it off when we're 3 degrees above the unoccupied set point. So let's do the unoccupied set point plus 3 degrees. So unocc heating plus 3. So there's our heating set point, and let's add 3 onto that. And then, so at 63 Fahrenheit it will stop. Let's put a Fahrenheit there. Unoccupied heating, unoccupied heating. So that's 63. So when that temperature goes above 63, so I want that to be a less than. I have to think about that. Less than. Where are you? Less than. Less than or equal. Less than or equal is good enough for me. I didn't expect that. I expected that. So let's test that now. So we need to get to 64 on that, for example. Set to 64. And that goes off. So that is going to be unlock off. View AX slot sheet. Unlock off or on. I'll put it on, meaning true. And rename. Really, that is going to be unlock off. So let's just change that to the same. Unlock off. So that's that one done. Unoccupied heating mode for space temperature is 3 degrees above space temperature rises above the unoccupied cooling set point. The fan will turn on and operate in occupied. So we want exactly the same, but this time we want it for the cooling. Space temperature rises above the unoccupied cooling set point. The fan will turn. So space temperature, so that's 85. So let's put that to 86. As a test, and we take the unoccupied heating, we duplicate that to unoccupied cooling. We take our control variable and we take our set point, and we're going to unoccupied right. So it's less than, so we've got to go for subtract. So unlock cooling -3. Take away 3. Put the facet on there. So that needs to be enabled at the moment. So we can reverse that around. So that's now true. And that's going to be rename Unoccupied heating off. So the other one's greater than or equal to. We're not cooling off. And we need, that's coming from the room temperature. And that is coming from the temperature there. Wrong way round. Room temperature at the bottom. That up there. And duplicate that. Unlock cooling. Pin slots. Bring up that. Pin slots. Pin that. Oh, enable, because we're unoccupied. True. Unoccupied cooling. Cooling valve, we're there. So, where are we now? The unoccupied cooling set point is there. So that needs to be into there. Ah, that needs to be true. So let's come off there. What have I done here? 82, oh no, yes, it needs to be true. 82 and 86. So 82 and 86. With the space temperature right above the unoccupied cooling set point, which is 85 and we're at 86. Cooling mode. Yes, we're in cooling mode. Until the space temperature is 3 degrees below the unoccupied cooling set point. So 3 degrees below. So that is 82. Let's just put 81 for the moment. Or 82. 82. Gone off. But not what the one I expected to go off. That's gone off. But let's just put that to 80. Yeah, it's gone off there. Doesn't make any difference, it's still gone off. So that's fine. That's just an extra backup, that's all. Same as that's going to be an extra backup. Just move that up there, like so. So that's our heating. So that's that bit done. Okay, yeah. So that's C done. Just move that one across there, like that. Right. C, D, short one here for D. New text block, note, D mode, save. If the fan coil unit is set to off, the fan will be off and both the hot water and chilled water valves will remain closed. Yeah, that's going to happen anyway. So no, so let's put it into unoccupied mode, or, well, we know it's going to work, but let's just do it anyway. So actions, set that, I don't know, to 86. We're in heating mode, cooling mode, sorry, fan enabled. But if that mode action set is in the off, aha, I was wrong, it wasn't going to work. So that mode needs to go into our main safety mode up there. Views, AX slot sheet, mode. So now it goes off, and then we take it out of our mode there. We bring that into there. And we can take it from there to our normal mode there. Okay, that turns it off. Yep, that works fine for that line there. Let's put that back to auto. And it's back on again. Right, so that's that one settled with. The next one, D, E. I think we've done most of E, but let's put it in. New text block, note. Let's get my there, control key V. Yeah, we've actually done unoccupied. We've actually done E already. Move that across there. Paste that into there. Save. Okay. We've done E, like I keep saying to you. F. We haven't done F. So let's put F in there. Let's change that to that. Move that across to that. Control key C. New text block. Note. Paste. Save. Come back out. Scroll down. That's it. It's that. If the fan is commanded on, but the status is off for a period of 30 seconds, there will be a failure alarm. No one told me about a status. This is news to me now. So we've got a status on the fan coil. Okay. Oh yeah, that's fine. Low temperature alarm. Okay, provides a nuisance alarm on occupied. Provide a means to prevent a nuisance alarm on transition from unoccupied to occupied. Okay. If the fan is commanded on, but the status is off for the period of 30 seconds. So we've got a fan status, fan flow, whatever you want to call it. So Boolean writable, we'll call it fan status as a DesOps. Put a capital F. Still miss a capital F. Fan status, and it will be not on and off. It's going to be if it's an inverter, it's going to be running or stopped. If it's a flow switch, an airflow switch, it's going to be flow on, flow off. So we'll just do running and stopped. Save. Pin slots. That's going to be an input. Actions set, and we'll put it to stopped at the moment, but it is enabled, so that's fine. If the fan is commanded on, which it is, but the status is off, which it is, for a period of 30 seconds, there will be a fan failure alarm. Right, let's do a mismatch. So we use an XOR gate, call it mismatch. We put our enable on there directly from the very output, because in case someone overrides it. And we put our fan status in there. That's our mismatch alarm, or mismatch. And then we're going to put it is under alarms, so it'll be a failure alarm. So new Boolean writable fan fail. We need to put a time in there. On delay 30 sec. In fact, I might not put 30 sec, I'll just put on delay in case it's ever adjusted. Pin slots on delay active. We don't need the out not. Change that to 30 seconds. And we've got our true there, which is going to be our fan. So I'm just trying to line it up with that, and line it up with that. Bring that across one. Pin slots, take out 16. And the true is fan fail. Fan healthy. And let's stick an alarm on there. Scroll down. And we need it into there. An alarm. Extensions. Boolean change of state. Go OK. 2 off normal, so fan fail. Unhealthy. We don't need to do just a time delay because we've already put the time delay on. We could have just used this instead of putting in that other point, but so we don't need to there. Default alarm class. We leave it at default alarm class, fan fail alarm. Save. I actually didn't fan healthy. Save that. 2 off normal, auto fault, we get the alarm. We name that as alarm delay. And I think I am going to take something like that. Just checking that, yeah. Duplicate it. They've not asked for this, by the way, but I'm still going to do it. They've not asked for it in the deserts, but I'm still going to do this. Take that, go to time, go to seconds, minimum 0. So we got 60 seconds, 30 seconds, 60 seconds. I don't know, let's not go above 120, 2 minutes. Save. Action set, 60 seconds. Alarm delay time set point. Right, I need to now put in a divide. Where are we? Kit control. Kit control. Not a divide, a multiply. I need to put it into milliseconds. I don't think that's right. So 60 seconds is 1 minute. You're right, it is 1 minute. What did they ask for? 30 seconds. 30 seconds. Rename sec to millisec. So they can adjust the alarm delay time set point. So we are in alarm because we have a mismatch. As soon as the mismatch is, we don't have a mismatch, that alarm should clear, and it does. Let's just go into the alarms because we've not done anything yet with that, but let's just go alarm service and let's go to our alarms here and let's put in a recipient and a console recipient, and we take our alarm and put it into there. And there's our alarm. 7:41 today, 18th of Feb 2024. Right, I'll leave that at the moment. We haven't done any graphics, and we've still got more to do here. So if the fan is commanded on, stays off for a period of 30 seconds, there will be a fan failure alarm. Done. During occupied mode, if the space temperature is 5 degrees, which is adjustable, okay, you want that adjustable. So duplicate. Space above or below set point for 1 minute. That's what temperature. Space alarm temp. Space temp alarm set point. Action set to 5 degrees. Yeah, okay. Okay, I know. Cancel. Put a minimum and maximum in there. Minimum 0, maximum 10. Okay. Save. Actions set to 5 degrees. If during occupation mode, so it's only occupied mode, the space temperature is 5 degrees or adjustable above the or below the space temperature set point for 1 minute. Okay, so how are we going to do this? So that is our above or below space temperature set point. Occupied mode, if the space temperature, okay, we've got that, that's our space temperature. We've called it space temperature, maybe we should, let's rename that to space. So we're with the desops. We've got an adjustable there of 5 degrees. So we could, yeah, we could put a T-stat in there. Let's duplicate that. We're going to rename it in a bit. And it's 5 degrees. Well, the diff works on, if I put 5 in there, that's not going to be any good to me because it's going to be plus or minus 2.5 then. So we need to times that 5 or whatever they're going to set the set point at. So let's multiply that. Kit control. I could have pulled a multiply from up above, but I'll just bring it from here instead. Multiply into there. Rename that T-stat diff. That's where it's going to go. Times by 2. There's 5 degrees either side. That's our diff. This is going during occupied mode. Temperature alarm, low temperature alarm accordingly. Okay. Rename that as temp. No, I better put temperature because it's not a temp alarm, is it? Help if they spell temperature right. So control variable. If during occupied mode, if the space temperature above or below set point. So the set point is there. No, it's not. The set point is there. That's my set point. Even though it's 72, we had to add on the 2 degrees. So that is my set point that I'm interested in. Not. So I'm just looking at this now. Do I actually, oh no, that's my cooling and heating. But do I change that set point? No, that stays the same. Oh, thank God for that. But does that, yes, because I'm adding it, I'm taking it away. Okay, so that is my set point. Or do I use their set point? During occupied mode, if space temperature is 5 degrees above or below space temperature set point. That is actually going to be the space temperature set point, but I better use their set point. So no, otherwise they're going to get a bit confused because they're not going to see this plus and minus. So let's use their set point. Like so. 72. Okay. 5 degrees either side of that. Which were 86. We're definitely 5 degrees either side of that. So that is going to be a false, and I'm cooling. So that's going to be a high temperature alarm. One better would provide a high temperature alarm or low temperature provided means to prevent a nuisance alarm. Okay. And we've got for 30 seconds. 30 seconds again. Duplicate. And temperature. Temp. Alarm delay. And it said occupied mode, during occupied mode. So we need to be in occupied mode for that to work. So we've got an AND gate there. We put that baby into there, and we've got the occupied mode. We must be in occupied. Occupied. Use AX slot sheet. Occupied. Temp alarm. And we got our delay. And if that's true, we're going to have to put a NOT gate there. So that's cooling. True is cooling. Use AX slot sheet. Okay, true is cooling. False is heating. We don't want that in there. That's cooling and heating. We're not occupied at the moment, so we're not going to do an alarm. But if we was occupied, that's going to go straight into alarm. So let's just duplicate that one. It's already got an alarm attached to it. And we need an AND gate. Heating. Rename. Heating. High temperature alarm. Low temperature alarm. So if it's cooling, if it's not getting to the heating one, low temperature alarm. Put these in capitals. Okay, and save that. I think what we'll do here in that alarm is we'll put a time delay on there, and for initial starting. No, we won't. We'll leave it as it is. We'll put a time delay in the logic. Low temperature alarm, duplicate, high. High temperature alarm. High. 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 Right. I need to change the text. This one's high. And this one, what we'll just use, but then just go back in and change low. If I've done that, 5 degrees has done that, 1 minute, space range set point for 1 minute. For 1 minute. High temperature alarm or low temperature recording. Provide a means to prevent a neutral alarm transfer from unoccupied to occupied. Well, it's only going to work when it's occupied. But we need at least a breathing space if it's high and it's unoccupied, and then we suddenly put it to occupied, which we will do now. We certainly don't want the alarm to go for a while. So that's occupied. We're enabled, we're in cooling. And we don't have an alarm. Above or below space temperature set point for 1 minute. So space temperature set point is 72. Sorry, it's 86, and we're definitely above it by 5 degrees. So I'd expect that to be on. And now it's timing the 1 minute. And it would come up high temperature alarm. But that's because we just turned it on. So what we want to do is we want that on delay to change itself. Time. We want that on delay time to change itself because we're going to get that alarm in a bit. So what I think I will do is I'll put in a numeric switch. First start. And then let's just switch everything off.